So any questions on any of those particular problems I could help you with? Yeah.
Can we go over like number 7, just like fraction?
Absolutely. Thank you for asking for that one. X to the fifth plus 5 third root of x. Okay, so the weird thing about this, the nice thing is when you're dealing with, you don't have like natural log or sine or cosine or anything like that that are coming along with it. Derivatives are relatively simple as long as you kind of remember some of the rules with algebra. So I'm going to convert this to 3x to the negative 4. That's because this wants to move up. Plus 2x to the negative 5, because that's moving up. And then I have to recognize that the third root of x is x to the first, so this becomes x to the 1/3 power. So I get plus 5x to the 1/3. Okay, so that's the first thing you have to deal with before you start doing the derivatives. Start getting, it's okay to have negative exponents, especially if it gets them out of a denominator, things like that. So if we do the derivative, if you remember, we're going to do f prime. That means we're going to go ahead and start the derivative. That's kind of a shortcut rather than putting dy dx. Okay? So this is going to give me negative 12x, and I always subtract 1 from the exponent. So negative 4 minus 1 is negative 5 plus, oops, it should be minus now, minus 10x to the negative 6, okay, plus 5/3 x, and if I go 1/3 minus 1, did you get it all done? Sweet, I'll get that graded for you. Thank you. You have to realize if I have this is the same thing as 3/3, so this gives me negative 2/3 once I subtract. And that's basically my derivative. Once you have your derivative, depending upon which course you're in, they might want you to move the exponents back down. I don't think it's totally necessary for this class. So take care of that. Dalton, did you have yesterday's homework by chance?
No.
Okay. Let me go drop this on my desk real quick so I can read this. Any others you want me to take a look at? Friends, we feel okay? Remember the derivative of a constant, it's always 0. Okay? So a derivative of a number would be just 0. Okay? We good on all the rest of those? All right, so let's go to the top of that page, that worksheet 4.3. I'm still on 4.3. And I want to talk to you about how certain things happen. So the first problem, they tell us that we have this as our equation. So for letter A, they want us to find f prime at x. So that's going to give me 4x. 2 minus 1 is 1. You can put that. This is to the first. So this is going to give me a negative 1. And then if I subtract, the reason why I don't have an x with this is this becomes negative 1x to the 0, because if I subtract 1 from that, okay? And then remember, if I have a variable or a number raised to the 0 power, it comes out to 1, so that basically became negative 1 times 1. So that's our derivative. Jack, did you have yesterday's homework?
Yeah.
Take your word for it. All right, so that's the answer to A. Then they want us to find the instantaneous rate of change. OUS instant. Oh my gosh. Instantaneous rate of change at f of x at x equals -1. Okay, so what this means, instant rate of change means you have taken the derivative. Okay, means you're looking for a slope now. Rate of change is slope. Instantaneous rate of change is the slope exactly at that point. And we want x equals 1. So what I'm going to do is I'm going to take f prime at x, my derivative, and I'm going to replace the x with a 1. Oops, that should be a -1, sorry. So I'm going to get 4 times 1 minus 1, which is 4 minus 1, so it's 3. So on our graph, on our original graph, which this is a parabola, so it should look something like this. If I got to 1 here in the x direction, if I got exactly to this point right here, the tangent line slope exactly right there, the slope would be equal to 3, or 3 over 1. Yeah.
Should it be negative because it's a -1, not a 1?
Oh, it's supposed to be a -1. That was a negative. That's a negative. So that should be -5 then. So that means at -1, bless you, at -1 right here, this slope right here, the slope of that red line would be -5. Okay, or -5 over 1, so down 5, right 1, at that exact point. Okay? And then it says find the point on the graph. So then we want to find the point on the graph of f at x where x is equal to -1. And what I'm going to do with that is I'm going to take my original equation. I'm going to plug -1 in. I'll do it right this time. -1, yes. So I get 2 times -1 quantity squared minus -1. Do the algebra there. That's 2 times 1 plus 1. So that's 2 plus 1. Bless you. So that means that the point -1 comma 3 is a point on our graph, on our original graph. And then we know that the slope from our original graph is going to be -5. Okay? Now, what that could turn into, and it doesn't ask us on our problem itself, is if we wanted to find the line, the equation of the line, and that we're talking about the tangent line. If we wanted to find the equation, we'd use this equation, which is called point slope. And the nice thing is we have x1, y1, and we have a slope, so we'd get y minus 3 equals -5, x plus 1. And I know it didn't ask for it, but that would be, and you're allowed to leave equations of line and point slope form. You don't have to solve it y equals, especially now we have Desmos. Desmos would take it. So if I did this, y minus 3 equals -5, x plus 1, and my original equation was this. So what's happening is that, and I'm using Desmos to be more of a visual so you kind of have a little bit of a comprehension of it. Excuse me. Hey there. So I'm going to plug y equals 2x squared minus x. And then because we found the derivative, and the derivative at a point allowed us to find the slope, if we plug in our point slope equation, And this is where Desmos, I think, has better power than our graphing calculator because we can plug it in whatever form. Okay, so what this is doing is, you come up to right there. That right there is the intersection of our two lines. Now, the intersection means the blue line, that's the tangent line equation, and the red parabola, that's where they would touch each other. So that technically becomes a solution. So if we wanted to know, if we did this, if I went down 5, so 1, 2, 3, 4, 5, and right 1, it still exists. So I gave you more information about that problem number 1 on worksheet 4.3 that we're just kind of looking at it notes. So that's the long and the short of everything that's taking place with a derivative. So that blue line is tangent. A tangent line touches our graph, our original graph, 1 time exactly. And the thing to note is as I come down this blue line as I come down changes until it gets to 0, and then it becomes a positive slope on the other side. So those are things that are taking place with it. We certainly could find a whole bunch of tangent lines if we deemed that was fit, and that would kind of be a discovery thing, but we're not going to do that. Okay? For number 2, on that same worksheet 4.3, says for problems 2 and 3, over what intervals is this increasing or decreasing? So let's draw our XY axis. And Stirup's going to do his best to okay, hopefully that looks similar. So this is point A, point B, point C, point D, and point E. Okay, so we're going to base this. So for problem number 2, letter A, over what intervals A through D, so we're looking between the points A through D, is the rate of change positive? Okay, so what we're going to do is we're going to look at our graph. So this would be 0. Now my slope is a negative slope. If my hand was a line, agreed? And it changes a little bit, it follows this line, gets exactly here to C where it has a slope of 0, and then it's going to start going up. So from A to D, where is the rate of change positive? From point C to point D, it's positive, meaning if I had a tangent line, if I'd taken the derivative, if I knew what this function was, as far as an equation, if I took the derivative, if I were to plug in values between C and D, so it's soft bracket C, hard bracket D. Now, the reason why it's a soft bracket at C is the line. The line exactly right here would be a horizontal line. The horizontal line has a slope at 0. As I start moving up like this slope is increasing. It's positive. And then D, right exactly at point D, it stays as positive. So point D is definitely a positive slope. Starting at the next smallest number in the world from point C, so C plus 0.0 forever with a 1 at the end, it starts creating a positive line. Enoch, did you have last time some work done?
Yeah.
Yeah, we did that together, right?
No, we did some of that.
Okay, cool. Thank you, sir. All right. So, is that making sense, friends? Okay, so for letter B, It says over the interval from A to D. Okay, so same interval. Where is the rate of change negative? Meaning if I were to take the derivative and I were to plug in a point between A and D, where would it say negative? Well, exactly at A, it'd be 0, and now it's coming down. So from A to C, not including A and not including C, because exactly at C it's horizontal, exactly at A it's horizontal, which should be up here. That's where we would have a positive or a negative slope. So from A round bracket to C round bracket, any of the points in between A and C, if we found the slope, the instantaneous slope, we plugged into our derivative, we would get a positive number or a negative number. Okay, we're looking at negative. Okay, so at these 3 points, the slope is 0 because it makes a horizontal line. Okay, points B and D are actually called something called a point of inflection. We don't have to know that yet, but what a point of inflection does is this. My tangent line is like this right now. As I come down, it stays tangent. Okay, and what happens right at point B is this magically flips over to the other side of the equation. It goes from here to here. That's what's taking place with the point of inflection. We don't have to know that yet. It'll be something in the future that we'll look at. All right. Letter C says, at what points A through E does the rate of change equals 0? Okay. And that would be at point A, at point C, and at point E. Because my tangent equation, my linear equation that is tangent, means it touches my graph once at exactly that point. At A, C, and E, we would have a value that's 0. Questions on any of that I just kind of covered. So it's kind of a lot different information. If you've taken pre-calc, you've heard this information before. If you haven't, this is brand new to you. Okay. And then, oops, I'll go back. And problem number 3 says, at what points A through E does the rate of change from positive to negative? Where does it go from positive to negative? Okay, so we're going from A to E. So from A to C, we have negative. From C to E, we have positive slope. Okay, it's rounded brackets at the A and the C and the E because those points are exactly 0. Okay, they're either a high point or a low point. It changes direction. And what this is leading to is if I had some sort of number line and I wanted to represent our graph that wasn't graphed in 2D, what we could do is we could say it's negative here, B to C is negative here, and then it's positive and positive, and you would put a circle at the critical values. The critical values are basically where it's going to change from going down to going up. Okay, so this is something we will actually take a look at. We'll actually have problems later in the future that'll say, hey, we have this is our sign line. What do you know about it? And this would just say my slopes are negative, and then this would tell us our slopes are positive. It doesn't tell us an actual what the slope is. It just tells us that with how our graph it would be doing 2-dimensionally when we're looking at a 1-dimensional. And then that was for A. And then letter B on 3 says at what point of points A through E is the rate of change from positive to negative. So positive to negative. Oh, I guess I didn't answer this one. So right here, at point C, it goes from negative to positive, okay? Or if you want the opposite way, positive to negative. And then where does it change from negative to positive? Again, if you looked at our sign line, it's just at point C. I guess theoretically we could say this doesn't exist on this. Okay? So that's kind of some thick meat and potatoes. All right, I'm on the second page, number 8. Curve. Okay, I think without a doubt in my mind that you could totally handle, especially using Desmos, worksheet 4.3, and I'd like you to do 8, 9, 10, 11, and happy to help you. I guess this will actually be due, let's make this due tomorrow, and I'll check that off tomorrow, go over them, and then tomorrow, which is Friday, we will do our fair division conversation. So other things to know, there is a quiz on Schoology, and it's due at 11:59 p.m. on Friday. The nice thing is it's resumable, so you don't have to do it all at once. Please work with each other if you'd like. Consult with people and see how you do. But I definitely want to get that done. And there are 2 of you that still have the old quiz on Schoology. It's still open. I just need you to take it so I can get a scoring for you, because unfortunately your score right now is a 0. And I'm pretty sure you know more than 0. Okay? Sound good, friends? Everyone happy?